Hello there, 7th graders. We are actually going to go to section 4.6, which covers arithmetic sequences. Now, what is an arithmetic sequence? We're going to figure that out. We're also going to write the terms of arithmetic sequences, graph them, and write them as functions. Now, here's the good news. The first part of this is pretty easy, and then it's not so much. So, we're going to take what we already know about sequences and apply it to functions. All right, so we're going to first start with some terminology. So here we go. A sequence is an ordered list of numbers. So here we go, 5, 10, 15, 20, 25. That's a sequence. Each number in the sequence is called a term. So like the 5 would be in the first position. The 10 would be in the second position. The 15 would be in the third position, and so on. And we got our little lightsaber back. Now, each term, a sub n, has a specific position n in the sequence. So, a sub n is the term that is in the nth position. So, an arithmetic sequence, since it is Star Wars season coming up here, where we have to use lightsabers, the difference between each pair of consecutive terms is the same. So as you see here, 5 to 10, 10 to 15, 15 to 20. That's what makes an arithmetic sequence. If you don't have that common difference, it's not an arithmetic sequence. So that difference is called the common difference. Each term is found by adding the common difference to the previous term. Now the common difference can also be negative, which is basically subtracting each time. So you could add a negative 5, add a negative 5, add a negative 5 to each term. Now to add on to that, an ellipsis is this parenthesis, and then dot, 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 is a series of dots that indicates an intentional omission of the information. In mathematics, the dot, dot, dot notation means and so forth. The ellipsis indicates that there are more terms in the sequence that are not shown. So the dot, dot, dot is actually read and so forth, and it's called an ellipsis. Example 1, we're going to start with an easy problem. Write the next 3 terms in the arithmetic sequence. Well, as you can see, going from negative 7 to negative 14, we're actually adding a negative 7. We're adding a negative 7. We're adding a negative 7. So then the next 3 numbers in the term would be negative 35, negative 42, and negative 49. Now the next thing we're going to go over is to graph the arithmetic sequence. To graph a sequence, you're going to let the term's position number n in the sequence be the x value. The term a sub n would be the y value. So the x, this is important. If you plug in 1, that means the number in the first position. If you plug in 2, that's the number in the second position. A sub n is the actual number in that position. So the ordered pair is that. N, a sub 1. So we're going to graph the arithmetic sequence 4, 8, 12, and 16. So in our t-table, n is the numbered term, so the position would be 1, 2, 3, 4. The term a sub n is the y value. So the first term is 4, the second term is 8, the third term is 12, and the fourth term is 16. If we graphed it, we label the x-axis n and the y-axis a sub n, and we graph all 4 points. What do you notice? The points form a line. So let's look at the next one. In this example, we're given a graph. Does this graph represent an arithmetic sequence? Well, we just have to look at this and ask ourselves, what is the first number in the position? Or the first term, the first number, what is that term? So if we look at it, we can see that the position, the first position, the number is 15. Then the number is 12, 9, and 6. So as you can see here, the common difference is what? We're adding a negative 3. So since consecutive terms have a common difference of negative 3, the graph represents the arithmetic sequence. So that's your explanation. Since the common difference is negative 3, the graph represents an arithmetic sequence. That's what you'd write down for your answer. All right, now this is where it gets a little confusing. We're going to now write the arithmetic sequences as functions. Because consecutive terms of an arithmetic sequence have a common difference, the sequence has a constant rate of change. Whoop, whoop. Make sure we note that. Constant rate of change. The reason it's a constant rate of change is because it makes a line. So the points represented by any arithmetic sequence lie in a line. Yeah, I just said that. You can use the first term and the common difference to write a linear function. Make note, I want you to put a star around this. What do you need? The first term and the common difference to write a linear function. A sub 1 represents the first term. D represents the common difference. So let's look at what all of this means. Position, that's n. 1, 2, 3, 4 are ellipsis, and so forth, n. The first term, the second term, the third term. So what do? You take that first term and you add the difference. The third term, you take the first term and add twice the difference. You take the fourth term, notice this, the fourth term, and then you do the third term times the difference. So you're taking 1 minus that term. So your formula is this. You are taking the first term, you're then adding n minus 1, n representing the term, multiplied, I'm sorry, not the term, n represents the position, not the term, multiplied by the common difference. And here it is. If we let a sub n be the nth term of the arithmetic sequence with the first term a sub 1 and the common difference d, the nth term is given by this. A sub n equals the first term a sub 1 plus n, which is the position, minus 1, multiplied by d, the common difference. Now, there's something you should note about this. This is interesting. This is where we get this from. And here it is. An arithmetic sequence is a linear function whose domain is the set of positive integers. You can think of d as the slope, and 1 a sub 1 as the point on the graph of the function. An equation in point-slope form would be this. Remember, this is y minus y1, but since y is now a sub n, it's a sub n minus a sub 1 equals the slope, but the slope is really the common difference. And then remember, your x value is really n. If we add 1 to both sides, a sub 1, you get a sub n equals a sub 1 plus d multiplied by n minus 1. Notice that this is really point-slope form, just with different meaning, different values. So example number 4. Write an equation for the nth term of an arithmetic sequence, 14, 11, 8, 5, and so on. Here's what the purpose of this is. Why do we do this? Because you're not going to want to go to 50 terms to figure out what this is. Obviously, you can see you're subtracting 3 here. Do you really want to subtract 3 50 times? Probably not. So we're going to first write a function and then find that term. All you need to know is this. A sub n equals the first term plus n minus 1 multiplied by the common difference. So a sub n equals the first term, which is 14, plus n minus 1 multiplied by negative 3, which is the common difference. And now all we do is write it in slope-intercept form. We solve it for y, which is a sub n. So I distribute the negative 3. That would be negative 3n plus 3. And if I simplify, I get, let's see, negative 3n plus 17. Pretty easy. There's my equation. So now I plug in 50. Easy, easy math. 50 multiplied by negative 3 is negative 150 plus 17. So what does that mean? It means the 50th term, a sub 50, equals negative 133. Voila, that's it. All right, so our final example. You can rewrite the equation for an arithmetic sequence with the first term, a sub 1, and the common difference d in function notation, basically taking the y value and making it f of n. That's it. The domain is always the set of positive integers. Here's the reason why. If we're talking about position, you can't have a negative or 0 position. So it's always the set of positive integers. So a real life example. Online bidding for a purse increases by $5 for each bid after the $60 initial bid. So the bid number, 1, 2, 3, 4, and the bid amount, $60, $65, $70, and $75. First off, write a function that represents the arithmetic sequence. Well, the first thing we do is plug in f of n. Our first bid amount is $60 plus n minus 1 multiplied by d, the common difference. What is that? What is the common difference? Good, it's 5. Pause the video and solve this equation for f of n. Pause it. All right, what'd you get? If you did it correctly, you should get f of n equals 5n plus 55. So there's A. B, graph the function. And C, the winning bid is 105. How many bids were there? Well, we're going to skip B for now, but C, I'm just going to do it right here. I could plug in $105, which represents the bid amount. That's f of n. That's your y value. Equals 5n plus 55. Solve that. Easy. 105 minus 55 is 50. And that means n equals 10. So there were 10 bids. And for part B, there's your graph. We'd label everything. Make sure you put n and f of n or a sub n there for bid amount and bid number, and we have a title. Notice that it is discrete since you can't have part of a bid. And that's it.